Question 24 offers us a complex geometric shape. Each of these individual shapes here around the edge are octagons, and we're supposed to find the area of the shaded area given that each length of the side of the octagon is length A. So let's have a go at it. I think with any of these geometric problems, we need to break it down into separate shapes. The shape I think we should identify first is this square. It must be a square because it's made up of equal elements on each of its sides. So let me highlight that first. So let's start by putting dimensions, especially along this top edge of the square, relating to the length A, which is the side of each of these sides of these regular octagons. Well, that's an A there. That's an A there. This sloping side of the triangle is A, and so is that. We don't know the base, so I'm going to call that X. So we clearly need to express X in terms of A. So the first question we've got to answer is, what's this angle up here? Well, it's the same as this angle here. And the two other angles of this triangle, which is the same as our triangle, are the exterior angle of a polygon, and that is equal to 360 divided by 8, which is equal to 45 degrees. So if these two guys here are 45, the top angle must be 90. So our AAX triangle is a right-angled triangle, and we can immediately apply Pythagoras. So I can say x squared is equal to 2a squared, and therefore x is equal to a root 2. So therefore the length of the square must be equal to our x, which is a root 2. We've got one of those, but we've got two a's. And if I take an a out as a common factor, I get a 2 plus the root of 2. That's the length of the square. So the area of the square is equal to this lot squared, which is a squared, and then 2 plus the root of 2 squared, all squared. Multiplying that out, I get, this is 4 plus root 2 times root 2 is 2, and then from the underneath, that's 2 root 2, there's another 2 root 2, so this is 4 root 2. And that simplifies to a squared, 6 plus 4 root 2. Now, what about the area of these triangles? Well, if that you can think of as the base, the height is A. Half the base times the height will be the area of the triangle. So the area of the triangle is equal to half A squared. And we've got 1, 2, 3, 4 of them. So the area of the triangles is equal to 2A squared. So the total area will be the addition of the area of the square and the area of all those triangles, which is 2a squared plus this lot up here. Well, effectively that's the answer, but they want it in this form, so they've pulled out an a squared as a common factor, and they've got this constant p in it as well. So if we pull out that constant first, so this is equal to a squared, and I'm left with 2 plus 6 plus 4 root 2. And that is equal to a squared, 8 plus 4 root 2. And I think you can see that that constant p will be 4 because I can take a common factor of 4 out of this. So this is equal to, well, I'll do it in their way, which is 4, then the bracket, which now reduces to 2 plus root 2, and a squared on the end. So we've proved it, and that is your answer.